series.
Most people think of technology as something we hold in our hands. A phone, a chip, a screen. But the next wave of technology is smaller than you can see. They are nanoparticles, and they are already in our world, and to a degree in our bodies. What are nanoparticles, and how do they behave? Nanoparticles are materials engineered at a scale of 1 to 100 nanometers. At this scale, surface area to volume ratio, quantum effects, chemical reactivity, and mobility change dramatically. When introduced into biological environments, they tend to acquire a protein corona, layers of proteins that bind to the nanoparticle surface, thereby defining how the immune system sees them. For example, silver nanoparticle, ubiquitin corona, studied in experiments because of their small size. Nanoparticles can cross physiological barriers, lungs, bloodstream, blood-brain barrier, cellular membranes. Routes of human exposure and known risks include exposure occurring by inhalation, ingestion, dermal and contact, in medical settings, injection. The toxicity mechanisms are subtle and varied. Inflammation, oxidative stress, genotoxicity, DNA damage, mitochondrial dysfunction, and fibrosis. Some studies show engineered nanoparticles used in drug delivery and cancer therapy. In those cases, they are beneficially targeted, but uncontrolled exposure is more worrisome. Because they are so small, regulatory exposure limits designed for larger particles may not be protective enough for nanoscale materials. The transformations of nanoparticles in the body or environment, agglomeration, chemical change, make their tracking and risk assessment very complex. Let's talk about nanoparticles as biological interfaces in the biocipher continuum. Researchers already propose bio-nanothings, an internet of bio-nanothings, tiny devices or particles embedded or circulating in the body, capable of sensing, actuating or communicating with external networks. These could convert biochemical signals into electromagnetic or digital signals, and vice versa. In effect, your body becomes part of the sensor network. The security, privacy and control implications are enormous. If internal biological states can be monitored, manipulated or hijacked, your autonomy is at risk. These nanoparticles are not just passive pollutants. They might become nodes in the interface between you and the digital realm. Where do they appear? Environment. Nanoparticles can form in polluted air and industrial waste, entering our lungs with every breath. Food. Engineered nanomaterials are used in additives, coatings and packaging to change texture, color or shelf life. Pharmaceuticals. Nano drug delivery systems can target cancer cells, carry vaccines, or release medicines at the cellular level. Consumer goods. Sunscreens, cosmetics, textiles, and electronics all often contain nanoscale materials. You may never see them, but they're already inside the human ecosystem. What makes them powerful and risky? Their size. It gives them unique properties, more reactive, more mobile, more able to cross biological barriers. They can acquire a protein corona once inside the body, binding to biomolecules and changing how cells respond to them. This can be harnessed for medicine, but it can also trigger inflammation, oxidative stress, and DNA damage if exposure is uncontrolled. Scientists admit the long-term effects of chronic exposure are still poorly understood. The hidden layer. Nanotech as an interface. Beyond health and environment, researchers are already envisioning bio-nano networks, tiny nanoscale sensors that can circulate in the bloodstream, monitoring biological signals in real time. Nanoparticles that can act as communication nodes, linking your biology directly to digital systems. The Internet of Bio-Nano Things, IOBNT, where the human body itself becomes part of a connected network. If this sounds futuristic, remember, the groundwork is being laid now. The same properties that make nanoparticles useful for drug delivery also make them potential tools for continuous monitoring and even remote interfacing. But why does it matter? When nanotechnology blurs into biology, your body is no longer just organic. It becomes a hybrid platform, one that can be optimized, tracked, or even hacked. The question is, are nanoparticles the key to healing humanity or the back door to engineering it? This video is for entertainment purposes only. There's absolutely no link between the corona protein and the coronavirus. It's just coincidental they have the same name. There's also absolutely no cases of human beings showing up as devices on Wi-Fi networks.